In this video, we are going to solve example based on convolution sum using graphical method. In order to study this graphical method, we have the input signal x of n, which is discrete signal given as 1, 2, 2, 1, and arrow is placed at 2. Then we have the impulse response of the system h of n, which is again a discrete signal, which is given as 2, 0, 2, and here in this case arrow is not given. Now we are going to solve it using graphical method. So first of all, let us write the equation for convolution sum, which is y of n equal to summation k equal to minus infinity to plus infinity x of k into h of n minus k. Now in order to solve this numerical, we will need x of k and h of n minus k, which is the folded and shifted version of h of k. Here we are considering the function x and h is the function of k. Therefore, if you look at this equation h of n minus k, this h of k signal is folded first and then shifted by amount n. So we have to draw these signals. Now we will solve it step by step. So step 1, we have to draw x of k signal and h of k signal. So first, let us draw x of k signal. So this axis is k and y axis is x of k. Now if you look at x of k signal, this signal has values 1, 2, 2 and 1. So if you mark the indices of this, arrow indicates the origin of the signal. So this is origin, this is index of 2 element, and this 2 lies at origin. Towards left, 1 lies at -1, this 2 lies at 1 and 1 lies at 2. So these are the indices for these respective elements. Now when it comes to h of n, here we do not have arrow. In such cases, we are assuming that the first element is at origin. So its index will be 0, then 1 and then 2. So we have to draw these signals. So x of k, we have to draw from -1, 0, 1 and 2. So at -1, we have amplitude 1. So we'll draw a vertical line. At origin, we have amplitude 2. So this is at origin. Then at 1, we have again amplitude 2. And at 2, again we have amplitude 1. This is our x of k signal. Secondly, we are supposed to draw h of k signal. H of k signal starts at origin and it has amplitude. At 0 it has 2, at 1, and again we have to draw it at 2. So we'll draw it with other color. So let the value at origin is 2. So at origin, we have this signal 2. At 1, we have amplitude 0. And at 2 again, we have amplitude equal to 2. So this is our h of k signal. Now step 2, we have to draw h of n minus k. So here, two operations are involved, which is folding and shifting. So out of folding and shifting, according to precedence rule, we have to go with the folding operation. Therefore, we have to draw first h of minus k. K, here it is h of minus k. Now if we fold this signal will be shifted on the negative axis and this at 0 we will have amplitude 2, at -1 we will have 0, and at 2 we will have again amplitude 2. So here this h of k signal is folded along y-axis, therefore we get its replica on negative axis. Now step number 3. Here we have to shift h of minus k signal by amount n. Therefore this becomes h of minus k plus n, which can be represented as h of n minus k, which is the desired equation in the convolution sum. So we'll draw it. K, here I need is h of n minus k. Now the important thing to remember in this case is, whenever we are drawing h of n minus k, and if we look at the equation, h of minus k is added with plus n. Therefore this h of minus k signal will shift towards left. Okay, and one care has to be taken. Whenever we are shifting it towards left, it is shifted by amount n, and we do not know what is the exact value of n. So we are going to shift this h of minus k signal towards left, but it should be towards entire left of x of k. X of k signal starts at -1, so we have to draw h of n minus k signal before -1. So let's draw it. So I'll be marking these points. This is -1. So I need to draw this signal before -1. So first of all I will draw it. So this is the amplitude 2 at 0. Then we have amplitude 0. Then again we have amplitude equal to 2. So this initial amplitude was at 0, then it is -1, and then we have -2. So this h of minus k signal is as it is shifted, and now it is added with plus n. So in every coordinate we have to add n plus n. Here it becomes now n minus 1, and here it becomes now n minus 2. So simply shift h of minus k towards entire left of x of k and add n into every coordinate to get h of n minus k signal. Now step number 4 is to find out the convolution sum. Okay. In order to find out convolution sum, let us draw these both the conditions on same axis. So first is x of k signal. So it is 1 at -1, 2 at origin, 1, it is again 2, and at 2 it is 1. Next we have h of n minus k signal. So it is 2, 0, 2, and the corresponding coordinates are n minus 2, n minus 1, and n. So we have to find out the convolution sum. So at first condition, there is no overlap. So this overlap doesn't exist for what condition? Until this n is less than -1. We will not have any overlap. So this condition states that if n is less than -1, there won't be any overlap. Hence our summation will not exist, because in the equation of convolution sum, if we look at here, we need to multiply x of k with h of n minus k. And if there is no overlap, this multiplication is 0 into 0. So no multiplication exists, hence our y of n becomes 0. So now we need to find out where we can multiply this x with h. So now if we go on shifting this signal h of n minus k towards right step by step and obtain the multiplication, we will get the desired answer for convolution sum. So let us draw the next condition where the overlapping is going to start. For this again we have to draw x of k, h of n minus k with different value of or the desired value of n. So we have seen in initial condition that if we have this signal x of n and if the value of n is less than minus 1, there is no overlap. So in the next condition we will assume that n becomes equal to minus 1. Therefore this n will overlap at minus 1. So considering the value of n equal to minus 1. So if I draw it, I will just draw this signal. This is n coordinate, this minus 1 and n coincides with each other. We have n minus 1 with 0 and n minus 2 with amplitude 2. So for this case we need to evaluate y of n, and in this case whatever samples are overlapping, so here n and minus 1 samples of x and h are overlapping. So x at minus 1 is 1 and h of n with value of n equal to minus 1 is 2. So these two samples are overlapping, hence this multiplication will exist. So x will be 1 and h is 2. So y of n, now this is not n actually, it becomes now the value of n is now minus 1. So y of minus 1 is 1 into 2, which is equal to 2. Now in next step we have to shift n towards the right hand side again. So in this case the value of n will shift towards left, that is this n will be shifted at 0, and for this case n becomes 0, and now we are going to draw this overlapping signals. So minus 1, 0, 1 and 2. First of all draw the x signal, then draw h of n minus k shifted towards right. So at 0 we get amplitude 2, at minus 1 we have amplitude 0. So these points are, so at origin n is allocated, at minus 1 it will be n minus 1, and here it is n minus 2. So for this case our y of minus 2 becomes, just multiply and add the overlapping samples. So here we have overlapping samples at origin and both x and h has amplitude equal to 2. So 2 into 2, again we have one more overlapping sample over here which is at minus 1 and n minus 1. The value of the sample at x equal to minus 1 is 1 and value of h at minus 1 is now 0. So 2 into 2 plus 0, it becomes 4. Similarly, now the value of n will be incremented. so n equal to 1. So again draw the signals, both the signals in the overlapping form. So we have 1, we have 2, again 1, this will be your x signal. Now secondly, you have to draw h of n minus k. Now n equal to 1, so this will be n, this will be n minus 1, and this point will be n minus 2. So draw the corresponding signals 2, 0, 2, and find out the corresponding y of 1. So in this case, y of 1 is equal to multiplication and addition of all the overlapping samples. Starting from 1, we'll see at 1 both the signals has amplitude equal to 2, so x is 2 and h is also 2, plus the next overlapping samples 0, x is 2, h is 0, so 2 into 0, plus at minus 1 we have x as 1 and h as 2, so our answer comes to be 4 plus 0 plus 2, it is 6. Similarly, go for the next condition. So here the value of n will be equal to 2. First of all, draw x. So it is 1, here it is 2, here it is 2, and here it is again 1. Draw h of n minus k with n equal to 2. So it becomes n, n minus 1, n minus 2. So it is simply 2, 0, and 2. And find out corresponding y. So y of 2 is equal to, multiply the overlapping regions. So it is 1 into 2 plus 2 into 0 plus 2 into 2, which comes to be 2 plus 0 plus 4, again 6. Similarly, increment the value of n. Now n is equal to 3. So first of all, we will draw x signal again. And then we will draw value of h of n minus k. Now n is 3, so I need to mark this point 3. So n will be placed at 3, it will be n minus 1, and this point will be n minus 2. So again, now find out the value of y of 3. So y of 3 becomes, just multiply the overlapping region. So at n equal to 3, we do not have any overlap, so there is no multiplication exist. At 2, we have overlap, so it is x is 1, h is 0, plus at 1, both the values have amplitude 2. So answer is 4. Similarly, increment the value of n now to 4, and again draw the overlapping signals. Now h of n minus k, n is 4, so n, n minus 1, n minus 2. and find out y of 4. So y of 4 equal to, only one sample is overlapping, where x is 1 and h is 2, which is equal to 2. Now if we increment value of n equal to 5, if we increment this n equal to 5 and again draw this particular signals, we will not get any overlap. So this is x signal. Now our n is 5. So n minus 1, n minus 2. So this signal will not have overlap. Therefore, here y of 5 or any value for n greater than 5 will be 0. So ultimately, we have completed all the conditions for this convolution sum. So if we go from step number 1 again for the condition of n, so if the value of n is less than minus 1, there is no overlap, we do not have any convolution sum. The value of convolution sum exists from n equal to minus 1 to n equal to 4. And again for n greater than 5, greater than or equal to 5, we do not have any overlap. So this completes our equation, and lastly we have to specify y of n. So y of n in terms of curly braces, so y of n starts at n equal to minus 1, where we have value 2, then 4, 6, 6, 4, 2. So ultimately our answer is 2, 4, 6, 6, 4, 2. And arrow will be placed at the value at origin, so where n equal to 0, so n equal to 0 is at the second element, which is amplitude 4. We'll be placing this arrow at 4, and we need to draw this signal. N and y of n starts at minus 1, 0, 1, 2, 3 and 4. So at minus 1, we'll just mark the values 2, 4 and 6. So at minus 1, y of n is 2, at 0 it is 4, at 1 it is 6, at 2 also it is 6, at 3 it is 4, and at 4 it is 2. So this completes our numerical. The only condition you need to remember over here is, whenever we draw this x and h signals together, step number 4, here we have drawn these two signals together. You have to remember that you have to assume that this x signal is stationary and y of n signal is movable. So from left towards right, this your y of n signal will completely overtake your x signal. So you have to find out all the conditions of n. Therefore, this example you get the answer as y of n equal to 2, 4, 6, 6, 4, 2. This is your convolution sum.